So let's do a couple more problems. So here we want to determine if the following converge or diverge, and if it converges, find the sum. So this looks a lot kind of like a geometric sequence or a geometric series. So notice that the n in this case is only on the pi, whereas in the other previous problems, we had the n on both of these guys. So let me just move the 4 over. Okay, so move 4. Okay, so it's going to be the summation from n goes from 1 to infinity. I'm going to move the 4 over, and I'm just left with 1 over pi to the n. Okay, so notice that here, anything that's to raise to the power of n is always going to be equal to 1. For 1 to the power of n, you're always going to get 1. So the way that I can write this is summation from n goes from 1 to infinity of 4, 1 over pi to the power of n. Because we know that 1 over n is still going to give me 1. Okay, so now you see that this is actually a geometric sequence. Okay, well, this part is geometric sequence, but the whole thing is a series. Okay, r in this case is going to be equal to 1 over pi, which in this case is actually a number that is less than 1. So we know that this is going to converge. So converges by geometric series. So that converges by geometric series. Okay, so now since it converges, let's find the sum. So the sum is going to be equal to a1 over 1 minus r. So a1 in this case is going to be the number right in front of it, which is going to be 4 over 1 minus 1 over pi. Okay, so I'm going to put this into my calculator. So I'm going to have 4 divided by 1 over, 1 over pi. And what I get is approximately 5.868. Okay, that's going to be the number that it kind of converges to. Okay. All right, let's do another problem. So let's say we want to figure out the summation from n goes from 1 to infinity of negative 8 n minus 1 divided by n to the 9 to the power of n. Okay. All right, so now what you want to be able to do here is that you see that you have an n there and you have an n minus 1. So it kind of looks like it's already in the form that you want it in, but not quite. Okay, so what I'm going to do is I'm going to work with the top part, make it a summation as n goes from 1 to infinity. Okay, and make it this way. So I'm going to write negative 8 to the power of n, and I'm also going to break it up, negative 8 to the power of negative 1, okay, divided by n to the power of n, or 9 to the power of n. Okay, now notice that these guys have both a power of n. So I'm going to write summation from n goes from 1 to infinity of negative 8 over 9 to the power of n. Okay, and then you just have this negative 8 to the power of negative 1. This guy, you can just bring it to the bottom. So it's going to be the summation from n goes from 1 to infinity of 1 over negative 8. And then in the inside, you still have this negative 8 over 9 to the power of n. Okay. Now this almost looks like a geometric sequence, but now we need this to be an n minus 1. So this is going to be the sum from n goes from 1 to infinity of negative 1 over 8. I'm going to pull out a negative 8 over 9, and then you're left with a negative 8 over 9 to the n minus 1. So this equals to the sum from n goes from 1 to infinity. This thing is just going to be a positive 1/9. That's what this guy is. And then I'm left with negative 8 over 9 to the n minus 1. Okay, so now we have it in terms of a geometric series. Okay, so now notice that r in this case is going to be negative 8 over 9. If I take the absolute value of this, it's going to be 8 over 9, which is still less than 1. So by geometric series, it converges. Okay, since it converges, all we have to do is just find the partial sum. So S sub infinity equals A1 over 1 minus R. A1 in this case is equal to 1/9 divided by 1 minus R. R in this case is going to be negative 8 over 9. Okay, so let me go ahead and put this in my calculator. So I'm going to have 1 over 9 divided by 1 minus a negative 8 over 9. Okay, and what you're going to get is 1 over 17. Okay, or 0.059. Okay. All right. Now let's do one last problem. So let's say you have the sum from n goes from 1 to infinity of 1 over n minus 1 over n plus 1 plus 1 over 2 to the power of n. Okay. So notice that you have a couple things. So this looks very familiar. This guy right here is just a telescoping series. So you have the summation of n equals 1 to infinity of this guy, 1 over n minus 1 over n plus 1. And then you have this other stuff, plus the summation from n goes from 1 to infinity of 1 over 2 to the n. So this one, by telescoping series, is equal to 1. So this equals 1 by telescoping. So this is just telescoping. This guy right here is actually a geometric sequence. So it's going to be summation from n equals 1 to infinity of 1/2 to the power of n. So this is going to be equal to 1 plus the sum from n goes from 1 to infinity, 1/2. Pull 1/2 out, so 1/2 to the n minus 1. So you know that this is going to converge because r, which equals 1/2, is less than 1. So all we have to do is just find the sum. So 1 plus a1, which in this case is 1/2, over 1 minus 1/2. So I'm going to put this in my calculator. I'm going to have 1 plus 1 over 2 divided by 1 minus 1 over 2. And what that's going to give me is just a 2. So this sequence actually does converge, or this series does converge, and this is what it converges to. So you always want to be very careful. You want to pick out, does this kind of look like a telescoping sequence and series, or does this kind of look like a geometric? Does it look like a harmonic? And then based on that, you should be able to figure out what these sums are.